Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we will be discussing units and measurement lecture number 04. So in this video what we will be discussing? We will be discussing what is dimension and dimension formula of certain physical quantities. Okay, some fundamental quantity, also some derived quantities. As many as quantity we can understand, we will try to understand the dimensional formula for physical quantities. Okay. So, let us move on to the topic. So, here what do you mean by dimension? The dimension means the powers, dimension means the powers or exponents to which the fundamental units of mass, length and time must be raised to express it. Okay, what basically it is telling? It is telling basically if any physical quantity dimension you want to write, that one you have to write in terms of some basic fundamental quantities. Okay. So, suppose I am example try to understand. Suppose I want to write speed dimension. I want to write speed dimension. First I need to check what is speed formula. Now, speed is basically distance by time. Distance by time. So, distance is basically what? Distance unit is basically meter. Normal unit is basically meter. So, the meter will come here divided by how much will come here? It will come second. Time unit is second. Now, if a speed dimension I want to write, then I have to take the help of this meter and second, and I will write speed dimension as what? For meter I will put L equal to 1, for time I will put T equal to minus 1, because time is basically in the down, T equal to minus 1. So, this will be dimension of speed. That means what you are understanding? You are understanding you need to express any physical quantity in terms of some basic fundamental quantities. Okay, normally fundamental or SI based quantities we have to consider that 7 fundamental quantities we need to include here. So, here what this formula is telling or this expression is telling? This expression is telling in speed length occurs one time, time occurs like minus 1 time. Minus 1 time means it is like it in the down actually. Okay, it is in the below. So, that means numerator L and denominator it will be T. So, this is what, and T occurs also one time. So, this is the main idea you are understanding from here. Okay, and here you see they is not giving in any information about mass. So, what I will take here? Now, mass to the power 0, length to the power 1, T to the power minus 1. Okay. So, here this is the dimension of speed, and remember this bracket whatever you are writing, this bracket is called basically what? It is called symbol of the dimension. When writing dimension of any physical quantity, you have to put in this bracket that physical quantity and give it the dimension a symbol like this one. Then after you can understand how many times mass occurs in that physical quantity, how many times L occurs in that physical quantity, how many times T occurs in that physical quantity. Okay. So, here this power will tell you. So, that is why they are telling here this dimension is nothing but power or exponents. Okay. Exponents means also power. So, m power 0 means m does not occur inside the speed. L power 1 means L occurs only one time, but T to the power minus coming. So, minus means understand it will be denominator, this quantity in denominator, and its power also 1. Okay. Minus 1 means that is the thing. So, this is the way you need to find what? Dimension of any physical quantity, and most of the time we will take basically we will express like mass, length, time, and other fundamental quantities also like what? Current. For current will give basically ampere, for temperature will give basically Kelvin, for amount of matter will give mole, and for luminous intensity will give candela. Along with this one also we can include. These are basic fundamental quantities, but sometimes in question they will mention that you have to write a physical quantity with the help of some other physical quantity. Okay, not only mass, length, time alone, some other derived quantity also you can take, okay, instead of this fundamental quantity. That time there will be certain formula, certain rule we will need to follow, and we will make some equation and we will solve that, then after we will get the relations. Okay. Before that we need to understand what is dimensional formula for different quantities, and here while writing dimensional formula, one thing we must understand that, so when you are telling a quantity, it is a formula you must need. So, what you need first thing is formula. Second thing what you need, it is a SI unit. Suppose you want to write here, we are writing, so SI unit. So first you write formula, then SI unity. From here you can write dimension clearly. So these two things you must understand and remember. Okay. So this is the process for your dimension writing. First formula you should remember for that physical quantity, SI unity what, then from SI unity you can write the dimension how we wrote here. Okay. If a meter occurs one time, then L to the power 1, and second occurs in the down and power is 1, that is why T to the power minus 1. Okay. So this is the way we have to understand clearly. Okay. Now come to the next point. So here we will understand physical quantities. Now here the first physical quantity, I will take all fundamental quantities, I will take first. Suppose I am taking mass. If you mass dimension you want to write, for mass there is no formula needed, symbol only you know, symbol mass symbol is basically you give small m. Okay. Now formula needed, mass unit is basically kilogram, SI unity, and dimension when you are writing you can write here m to the power 1, L does not occur, T also does not occur, T to the power 0, T to the power 0, like this one you can write, or only you can write m to the power 1. Okay. So if this way also you are writing, you can understand you are writing about mass, or you can write also some other like fundamental quantities what you know. So m to the power 1, L0, T0, ampere for current, ampere A to the power 0, okay, mole to the power 0, or candela to the power 0, this all quantities you can write, okay, or K to the power 0, K to the power 0 also you can include. Okay. Now see this one basically here, see the power 0 means this does not occur in mass. So why we need to include this? No need this one. Most of the time either you write like this or you write like this one. Okay. So MLT most of the time we will keep. Okay. Now this is the about mass. Now we will understand about the length. So if I will go for length your unit will be what? Basically meter. For length unit is meter, and if I write only I can write L to the power 1, okay, or I can just write this term m to the power 0, L to the power 1, T to the power 0. Okay, this also you can write, but no need because these powers are not coming inside length. Length is a fundamental quantity, is independent of any other quantity. So that's why no need to keep that one in mind. Now come to the next point. Now here number 3, time. For time I want to write, so I can write here it is unit is SI unit is second, or SC, C basically can write, and here it is T to the power 1, T to the power 1, or you can write M0, L0, T to the power 1. Okay, this way also you can write. Now I will go to the next quantity. So all fundamental quantities we know. Number 4 I will go current. So that is basically electric current. So its unit is basically ampere. You can write ampere. So you can write it A to the power 1, or if you want to write you can write M0, L0, T0, A to the power 1. Okay, this way also you can write. Now if you want to write the next fundamental quantity, that is your fifth one, temperature. So temperature, then you can write here Kelvin, basically unit Kelvin, and it will be K to the power 1. And remember some books they will write basically temperature, or they will write in terms of theta. Okay, so Kelvin is unity, but they will write in terms of theta. So theta to the power 1 also they can tell. So that is also correct. I am writing K to the power 1. Then it is M0, L0, T0, K to the power 1, and A to the power 0, but I do not want to include. Okay, I just want to show MLT. Okay. Now next quantity come. So next quantity number 6th. Here amount of matter or amount of substance, quantity of a matter, that one also you can tell. Amount of substance, this is a fundamental quantity. Its unit will be what? Its unit is mole, SI unity, and you want to write same thing M0, L0, T0. So you just write mole to the power 1, mole to the power 1, right? No issues. Okay. Now here a next quantity come. Next quantity, 7th one, that is your luminous intensity. Luminous intensity. Its unit basically what? Its unit is candela. So you can write here it is candela unity, and here same thing you can write M0, L0 T0 candela to the power 1, write also candela to the power 1. Okay. Now we understand what is fundamental quantity dimensions. These all are called basically dimensions. Now we will go to the derived quantity. So in the derived quantity, so I will write in the point wise, I will write here. So write number 8. So it is your what? It is your area. First write area. So area symbol is basically we give A, and here area formula is what? Formula is basically length to the power 2. Area formula can be length into breadth or pi times radius square. So that means whatever you do or whatever geometrical picture you take, this area always comes basically somewhat distance square or length square. Okay, either it is a rectangle or it is a circle. So always area will be length square or distance square. Okay, and remember constants will have no dimensions and all. So for constant dimension I will be putting 0, that means like 5, 6, 7 normal these constants, but some constants can have dimension, that one also will discuss after discussing some physical quantities. Okay, now length square. So length square, so it is basically what? Now it is meter square. So meter square, so you can write it is only L to the power 2, or you can write M0 L to the power 2 T0. So this also I can write. Okay. Now come to the next 9th one, we will go for volume. So volume is basically capital V. So you can write this one as length to the power 3. Okay. So according to a geometrical picture, volume formula will be different. Suppose I will take a cube, then it is length to the power cube 3. Okay, that is basically volume. Suppose I will take a sphere, that is 4 by 3 pi into radius cube. So but here whatever volume formula, always it comes basically distance to the power 3. Okay, constants can change, but that constant like pi, 4 pi, these will have no dimension, so no need to worry about that. So you can write this one is what? This one is meter to the power 3, or you can write L to the power 3, or you can write M0 L3 T to the power 0. So this one also you can write. So this is your volume. Now next quantity we will write 10th one, that is density. Okay, density is what? Now density basically symbol we give rho, and the density formula is what? Now density formula is mass by volume, mass by volume. Okay, so unit will be kg, mass SI unit is kg, volume SI unit is meter cube. So it will be kg by meter cube with the SI unit of density, and you see in density mass occurs one time, volume occurs what? One time. So volume to the power 1, and inside volume length is power is 3, so it will be length power 3. That means length occurs in a density what? In the denominator it occurs, so that means L to the power minus 3. Okay, so you can write here m to the power 1 for kg and L to the power minus 3 T to the power 0. Okay, so minus means you understand it is in a denominator. Okay, yeah. Now we will go to the next quantity, which is basically 11th one. We will go for speed. Speed already I expressed in the first slide. Speed is nothing but what? Symbol you can give V. Speed or velocity also, right? No issues. Okay, but remember speed is basically distance by time, but velocity formula is displacement by time, and there is a difference between distance and displacement also. Okay, so here what will write here? Now here write suppose you write basically normally a formula, write it is length by time. Okay, that will be better. So length by time, so SI unit is what? Meter by second. So length occurs one time, so L to the power 1. T occurs in the down, so T to the power minus 1. I can write like this, or I can write m to the power 0, L to the power 1, T to the power minus 1. Okay, so this one also I can write. Now we will go to the next quantity, which is basically 12th one. Now we will write here acceleration. Acceleration. Okay, acceleration basically A. So what is this one? Now this is your nothing but velocity by time, or basically you can tell change in velocity by change in time. Okay, now here velocity by time, velocity is nothing but meter by second, and again another time is coming, so it will become meter by second square, or you can write L to the power 1 T to the power minus 2 directly, or you can write M0 L1 T to the power minus 2. So this one you must remember. Okay, wherever acceleration comes, okay, either acceleration due to gravity or a normal acceleration if you are telling, that unit will be meter by second square SI unity, and the dimension will be L1 t to the power minus 2. Now come to the next quantity 13 come momentum. So this is basically linear momentum. So this is what? This is your linear momentum. So what is a linear momentum? Symbol is P and formula is what? P is nothing but mass times velocity. Okay. So it is a vector quantity, remember velocity is a vector quantity, so that's why linear momentum also vector quantity. So mass times velocity. So mass unit is nothing but kg and velocity unit nothing but meter by second. So it is coming how much? Kg meter by second. So kg power 1 meter power 1. So kg power 1 means mass power 1. Meter power 1 means L power 1. Okay. So m stands for what? Mass, and L stands for length, and for t basically you can give time t to the power minus 1. Okay. So most of the time directly this question also asks what is the linear momentum dimension in your exam. So remember this one. Okay. And here this is the dimensional formula for momentum. Now if I want to write 14th one, I want to write what is dimension of force. Okay, force is basically called capital F. So force formula is F equal to ma, and remember when mass is constant, F equal to mass times acceleration. And here what is the unit of force? Now that will be for mass unit is kg, acceleration unit is meter and per second square. So kg into meter to the meter by second square, or you can write kg meter second to the power minus 2. Okay, or this one can be written as, okay, this is also can be written as Newton. Okay, so other name is given as Newton, or symbol you can write capital N. So this is the SI unit of force. Now here if you want to write dimension, then you can write what? Now m occurs one time, so that's why m to the power 1. Meter means L occurs one time, that's why L to the power 1. Second to the power minus 2, so that's why t to the power minus 2. Okay. So this is your dimension formula for the force. The dimension of force is m1 L1 t to the power minus 2. Now I will go to the next point. So 15th one will take. Okay. So here I will write basically what? Now impulse. Let me write impulse. So impulse symbol is basically given as, you can give either a J or you can give I, whatever you can give. Now here if I write formula for the impulse. So remember impulse is nothing but, impulse is either you can write change in momentum, or impulse you can write, okay, force into some small interval of time. Okay. So remember here there is a formula. There is formula what? Now force is also can be written as change in momentum by change in time, dp by dt. Okay, or delta p by delta t. Like this one also you can write force basically. So this is the actual definition of the force. So F equal to ma, F equal to dp by dt, and here this is the change in momentum and this is the change in time. Okay. And if you want to find change in momentum, then it will be force into delta t. So here impulse is basically nothing but what is that? Impulse is force into delta t or force into time, which is nothing but change in momentum. Remember. Now here remember. So here if you want to write unity, so force unit is nothing but Newton, and delta t unit is nothing but how much? Second. So I can write also it is Newton into second, or I can write, okay, momentum unity, because remember any physical quantity, it's a change if you telling. So change in that physical quantity, same unity or same dimension. Okay, suppose length unit is meter, change in length unit also meter. So momentum unit is kg into meter into second to the power minus 1. Similarly change in momentum also same thing. So I can write kg meter second to the power minus 1. Okay. Now here if I write dimension formula, then what will write? Write m to the power 1, L to the power 1, t to the power minus 1. Okay. So this is the way you need to proceed. I hope you are understanding. Okay. Now we will go to the next point. So here 16th one. So 16th one remember. So here write to kinetic energy. Kinetic energy. Okay. So kinetic energy basically Ke, and here what is kinetic energy? Now kinetic energy nothing but it is half mass times velocity square. Remember kinetic energy is what? Half mass times velocity square. Okay. So kinetic energy basically scalar quantity, but remember impulse is a vector quantity. So half mv square, and here if you want to write, So for mass, so half will have no unity or no dimension because it is a constant. So mass is having unity kg, v square means meter square by second square, or you can write what, kg meter square second to the power minus 2. Okay, or this one can be written as joule, or you can write capital J. Similarly, or you can write what, Newton into meter also. Okay, this joule also can be written as Newton into meter. Okay, we will explaining work, we will explain that one. So this formula I can remember. Now here if I write dimension, what will happen? Now kg occurs one time, m to the power 1. Okay, meter occurs 2 times, so L to the power 2, and t to the power minus 2. So is remember this one. So kinetic energy SI unit is nothing but that is what? Now that is your kg meter square second to the power minus 2, or m1 L2 t to the power minus 2 is the dimension. Okay. Now 17 come. Similarly, if I write potential energy, okay, potential energy. So potential energy you can write basically PE, or sometimes you can give it is your U symbol like that. Okay. So here what is potential energy? Now here suppose one object is at a certain height here. Okay. So here this height is basically h, this mass is m. So here if you write what is the energy possessed by the body due to this configuration, that means it is here but it is going to here, so it is shifting its position. So due to configuration what coming potential energy, now that is called mgh. Okay, mass times acceleration due to gravity into height, that is your gravitational potential energy. Okay, but there are some other type of potential energy there, like suppose here one spring is attached to a mass. Okay, now when you will stretch this spring, there what will happen? Now here one energy will be stored in the spring. Okay, or you will compress or stretch, whatever you do. So that there it comes potential energy called what? Now that is your elastic potential energy, that is half kx square. Okay, so whatever potential energy, when energy word mentioned, its unit is always basically joule, or SI unit you can write kg meter square second to the power minus 2, or you can write joule. Okay, or symbol you can give capital J, or you can write also Newton into meter. Okay, so this much idea you can remember. Now here you can write what I can write m1 L2 t to the power minus 2. Okay. Whenever physics energy term is coming, always remember its SI unit is joule and dimension should be m1 L2 t to the power minus 2. Okay, so this is most of the idea we understand about kinetic energy, potential energy, and kinetic energy is the basically energy possessed by the body due to its motion. So whenever a particle is moving, then kinetic energy come. If particle at rest, then kinetic energy 0 because speed will be 0. Understanding? And remember kinetic energy always is a positive quantity. Okay, it cannot be negative, never be negative. So remember this word. And here potential energy can be negative also. And whenever you are measuring potential energy, gravitational potential energy, that time this is basically the difference between this reference and this reference. What is the difference of potential energy? That is basically mgh. And this g is called nothing but acceleration due to gravity, and its unit will be meter per second square also. Okay. So what is the acceleration unit? Same unit will be here. So here we will understand work done. So what is the work? Now work is basically nothing but that is force into displacement. Okay, so force into displacement. Okay, this is normal formula, force into displacement. Okay, force will multiply displacement, but exact formula is F dot S vector. So this is a vector, this is a scalar quantity, and a vector dot product relations would be there between force and displacement, and sometimes also can be written as F dx, like this also you can write. Okay, so work symbol will give normally W. So F dot S, or integration of F dx or F dr, like that one also I can write. Okay, so sometimes I can write also integration of F dy, sometimes can F dz or F dr. Okay. Now here SI unit if I want to tell, same thing is force and displacement. So force unit is Newton and displacement unit is meter. So that's why force Newton into meter, or you can write this one as Fs cos theta, because dot product there means theta will come. Theta is the angle between F and S. So here what you can tell, now this theta or cos theta, they have what? No dimension. Okay, remember theta is basically angle, so it is a plane angle. So for a plane angle we have unit, that is radian, but it has no dimension. So cos theta will have no dimension, but or no unit, no unity, because cos theta when we will do now, when theta will put in cos or cos theta, when cos theta we are telling, cos theta is basically what? It will give a number. Okay, So minus 1 to plus 1, this value will be there always, minimum value minus 1 and maximum value plus 1 for cos or sin, whatever you are telling. So this will give a number. So number is having no unity or no dimension. So cos theta will not include. So force is Newton and displacement is meter. Okay, now here if a dimension you want to write, so you can write same 0 m1 L2 t to the power minus 2. Okay, this is a Newton meter, or you can write kg meter square second to the power minus 2, or you can write joule also. Okay, joule symbol you can give capital J. Okay, so this is the idea about your work done. This is your work done. Okay, 19, that is your power. Okay, power symbol is basically given as P, and power is what? Power is nothing but, that is basically work by time. Okay, power is nothing but work done by time. Okay, now here remember power is basically what? Work by time or energy by time. Okay, or sometimes you can write P equal to dW by dt. Okay, and P is a scalar quantity, sometimes can be written as also force dot velocity. Okay, so force vector dot velocity vector is basically power. Okay, so why it is coming now? Because you know F dW is nothing but I can write F dot ds, and here if I will take a dt this side, it will become ds by dt. ds by dt is nothing but velocity, which is basically v vector. So power is what? Work done or rate of work done basically. So work done by time, or you can write F dot v. So dot product of force into velocity. So whenever force and velocity given, you can find power like this, and its unity definitely it will be joule per second, or you can write kg meter square second to the power minus 2 divided by second. Okay, because here you have second in the down, so that one you can write also what? Kg meter square second to the power minus 3. Okay. Okay, or you can write, you see it is coming at Newton meter by second, you can write also Newton into meter by second, or joule also Newton into meter, so Newton into meter by second also you can write. Now here if you want to write the dimension, you see, so here how much coming, this is the final expression, here see kg power how much, that means mass power 1, meter square that means length power 2, second to the power minus 3 that means t to the power minus 3. Okay, this is the way you need to write, and this will be your power. Or you can tell work dimension already you know, so or you can write this way also what? Work dimension is m1 L2 t minus 2, and a time dimension is nothing but t to the power 1. Okay, then after this t1 will go up, it will become what? T to the power minus 3, and the m1 L2 t to the power minus 3. That way also you can calculate. Okay, or you can understand about SI unit also. So once you know the formula, then SI unity, then after your dimension automatically it will come. Okay. So that's all. So these are basically what linear mechanics. When we will study translational mechanics, this type of physical quantity will come across. Okay, starting from speed, displacement, velocity, acceleration, force, momentum, change in momentum, okay, and impulse, kinetic energy, potential energy, work, power. So this will come. Now I will go to certain rotational quantity. Okay, now see some SI unity and dimension of rotational quantities. Now I will write here 20. So here what? Now first rotational quantity, let me write angular displacement. Angular displacement. So what is angular displacement? Angular displacement given basically a theta. So whenever a circle is there, a particle is rotating here, suppose anti-clockwise it is rotating, this is the anti-clockwise motion rotating, particle is here, after certain interval of time it is going to here. So it is making some angle here, this plane angle making from this horizontal axis. So this theta is called basically what? Angular displacement. And remember, if you want to check angular displacement direction, then it will be what? It is vertically upward to this board, actually perpendicular, because anti-clockwise taking. So you can check with the right hand method, thumb rule. So it will be coming basically what? Now here it is coming like this one. This will be along this axis it will be there, and it is also basically what will take, it is axial vector, this vector quantities, but it will be what? It will be axial vector, on the axis it will be lying. So here angular displacement, what you can write? Now here we can write basically it's a formula. Formula no need to write here. Formula, and here SI unity. Okay, and here dimension. Dimension. Now, so here SI unit will be what? In a radian. Already in plane angle we have checked it is radian, or symbol basically give RAD, and the dimension if you want to check, it will be m0, l0, t0. Remember, so for angular displacement there will be dimension what, m0, l0, t0, because it will have no dimension. Remember, this is the quantity which is having unity but no dimension. Okay. So remember, a certain type of quantities will be there, they will having unity but no dimension. This is the example of that angular displacement. Okay. So it has unity certain radian but dimension will be not there. Okay. Now we will be going for number 21, that is angular velocity. Angular velocity. So what is angular velocity? Angular velocity is basically omega. Okay. So here formula is what? Formula omega is nothing but that is theta by t, that means angular displacement by time, or sometimes you can write d theta by dt also. Okay. So this is the angular velocity. So here it is what? It is radian per second. It is radian per second, or a dimension you want to write, you can write m0, l0, t to the power minus 1, t to the power minus 1. Okay. Remember, angular velocity, all other formula also there, that is basically 2 pi by t. Sometimes you will write that is called basically angular frequency, that same angular velocity also can be written as angular frequency. Okay. I will go to the next quantity. So here angular velocity also sometimes written as angular frequency, which is unit is nothing but radian by second also, angular frequency we can take. Okay. Now here let understand here also. So one is basically called sometimes time period. Okay. Time period is nothing but capital T, and there between angular velocity and like, or can tell angular frequency, this also I am writing here, it is angular frequency also, same unity, same dimension. So time period and angular velocity, what formula? It is 2 pi by omega, and remember here it is radian by second. So time period formula will come basically what? Now time period unity will come basically second. Okay. It will be second, or you can write m0, l0, t to the power 1. Okay. Understand this one? So time period also, that means time only, time period or time, that is same thing only. So time only. And here another quantity you can remember, that is frequency. So what is frequency? Now it is called linear frequency basically. So let me write it is frequency, or you can write it is linear frequency. Linear frequency is f, which is 1 by t, and other formula you can write basically f equal to 1 by t, and here you can write t equal to 2 pi by omega. Or if a particle of a mass m moving with velocity v in a radius r, then time period you can write 2 pi r by linear velocity v. This you also can write. Okay. Remember, if a particle moving in a circle, this time period can be written, and here 1 cycle per second is called basically what? A frequency. Okay. That is basically hertz unity, 1 hertz, or number of cycles per second, that is called basically frequency. So here f equal to 1 by t, or you can write second to the power minus 1, or you can write m0, l0, t to the power minus 1. So here this is the frequency unity. Remember, time period linear frequency, and the second to the power minus 1 sometimes can be written as what? Can be written as also hertz. Okay. Hz symbol, or you can write HERTZ. So this you also you can write. So hertz, or number of cycles per second. Okay. How many cycles are completing per second, that is basically your frequency. Okay. Because you are moving in the circular motion, or your rotational things it is happening, particle is rotating here. Okay. And if a particle rotating with velocity v radius r, then time period will be total distance cover, it is 2 pi r divided by its speed. So distance by speed is basically time. So from there only it is coming 2 pi r by v. So this much idea you must remember about what? Like derived quantities and its SI unity and its dimension. Okay. Now we will go to the next. Now 24. So we will understand angular acceleration. Angular acceleration. So what is angular acceleration? Symbol is given basically alpha, and formula you want to write. This alpha is nothing but that is tangential acceleration by radius r you can write, or you can write what? You can write d omega by dt. Okay. Rate of change of angular velocity. Okay. That is basically angular acceleration. Now here you see, so angular velocity unit already I know, that is nothing but omega that is basically radian per second, and 1 second is there. So, I can write SI unit as radian per second square, or you can write dimension m0 L0 t to the power minus 2, okay, because radian is having no dimension. So, m0 L0 t to the power minus 2 you can write. Okay. Now, write 25th number, that is here angular momentum. So, what is angular momentum? Angular momentum symbol is given basically L, which is nothing but r cross p. Okay, that formula is basically r cross p. It is a vector quantity, or sometimes you can tell it is moment of momentum. Moment of momentum is also called as angular momentum. Okay. So, when moment word will come, that time that r cross will come. So, r cross momentum. So, moment of momentum, linear momentum is basically coming what? Angular momentum. Okay. Now, here that formula you want to write. So, L can be written as you see, it you can write it is r cross p or rp sin theta, and sin theta and all will have no unity or dimensions. Now, here r is basically r, p is basically what? Mass times velocity, and sin theta you can write rmb sin theta. Now, here if I write SI unity, then it will be how much? Now, for SI unity, for this one, mass is there means kg will come, radius is there means meter will come, velocity is there means it will come meter by second will come. Now, or you can write this one what? Kg meter square by second to the power minus 1. Okay, understand? R is there, that is why meter, mass is there, that is why kg, and V is there meter by second. So, kg meter square second to the power minus 1, or this one can be written as what? M to the power 1 L to the power 2 t to the power minus 1. So, this is the dimension of what? Now, this is the dimension of your angular momentum. Okay. So, our moment of momentum. So, L equal to r mv sin theta, and sin theta will have no dimension or no unity. Okay. So, now we will go to the next quantity. So, here we will go to angular force. Now, we will go to the next quantity, which is angular force. Angular force, that is also called as what? Torque. Angular force also called as a torque. So, torque is basically what? Now, that is basically r cross f, or sometimes you can tell this one, it is what? Moment of force. This one also you can tell. Torque is what? R cross f or moment of force. Okay. So, here when moment word comes, you do cross product to do r first. So, r cross f like that you can do. And what is this one? That r cross f unity. Now, it is Newton into meter. So, you can write directly Newton into, sorry, formula let me write here. Formula is what? Torque formula is Rf sin theta you can write, or torque can be written as dl by dt. This formula also can write. Okay. So, it is like your linear force, you see, linear force equal to what? Change in momentum by time. So, angular force is nothing but what is that? Now, here change in angular momentum by time. Okay. Or you can write this one as what? This one you can write it is called also torque. Okay, tau. Okay. So, tau equal to dl by dt. And here from here you find what is SI unity. SI unit is nothing but R is there. So, R is means meter, force is there, that means Newton. So, definitely Newton into meter. Newton into meter is nothing but it is kg into meter square into second to the power minus 2. Okay. So, that means it is coming basically what unity? It is coming joule unity. Joule unity means its unity is same as work unity, or a dimension if you want to write m1 L2 t to the power minus 2, because kg to the power 1, m to the power 1, L to the power 2, t to the power minus 2. Okay. So, here remember torque unity or angular force unity or moment of force unity is what? Equal to work unity, or its a dimension also equal to work dimension. But remember both the quantity, okay, work and this moment of force, both are basically different quantity. Okay. So, it is a vector quantity, that is a scalar quantity. So, both are different quantity, but their unit and dimension is coming same. It can happen, okay, for a different quantities with a different meaning also, but their unit and dimension can be same, not an issue. Okay. So, it is a rotational quantity, and here there are certain relations, this cross product relation, when rotational quantity will study, there are certain cross product relations will come, you must remember. And here also in this case, that angular velocity, in this angular velocity and linear velocity will be some relations also there. If I write, I can write linear velocity is nothing but, what is that? That is here omega cross r. Remember, linear velocity is what? Now angular velocity cross r. So you are writing some relation between relation velocity, linear velocity and angular velocity. And already here we know about linear momentum and angular momentum, and here we know about torque. Okay. So linear force and angular force SI units. Similarly, here also you come rotational kinetic energy. So rotational kinetic energy unit will be same like joule only. Okay, as already we have discussed, any energy is basically joule unity or m1 L2 T to the power minus 2. Okay, so this is the thing is coming here. The next point, some other quantities you will understand. Okay, so here if I will tell, next point is angular impulse, angular angular impulse. So what is angular impulse? Now that you can write angular impulse, angular impulse. So here what you will write? Now same thing. So here impulse already you know what formula write. Now previously you wrote linear impulse is basically change in momentum. So here it will be nothing but what? Now it will be change in angular momentum, change in angular momentum, and its unit will be same type. Okay, and you can write, suppose the symbol I am giving as whatever, that is J prime, suppose I am giving, then I will write it is what? Force means torque into time. So this way you can write torque into delta T is basically angular impulse. Okay, or change in basically angular momentum. Okay, or you can write J prime is nothing but change in angular momentum. Okay, angular momentum unit already I know, that is MVR unit actually. Okay, so it is nothing but kg, okay, meter square second to the power minus 1. So this is the angular momentum unity already we have written here, kg meter square second to the power minus 1. And remember, angular momentum here, whatever this angular momentum is there, this angular momentum also can be written as nh by 2 pi, and here this h is basically what? H is called Planck's constant. So Planck's constant unit and angular momentum unit will be same. So you see h is a constant, but its unit is there. Okay, so that is basically what? Now constants having some unit or a dimension. So this constant will have some unity, that is kg meter square second inverse, or you can write joule into second also. Okay, so you can write joule into second. This is actually Bohr's postulate. So when you study in 12th standard atomic physics, that time Bohr's model, atomic model, that time we will study this one. L equal to nh by 2 pi. This n is a number, pi is no dimension unity, 2 also number. So h is Planck's constant and its unit is joule into a second. Okay. Now it is kg meter square second, or you can write what you understand, joule into second also you can write, no issues. Okay, because you are writing here torque into delta T, so you can write, or you can write Newton meter into second, because joule is nothing but Newton into meter. So Newton meter into second also write. But while writing dimension, this one only will help you, because here kg means mass to the power 1, meter square means L to the power 2, second means T to the power minus 1. Okay, that is your angular impulse. Now another quantity will go in the rotational also. Okay, 28, that is your moment of inertia. Okay, moment of inertia, that symbol is basically given as I. So what is moment of inertia? Now moment of inertia is nothing but it is mass into some distance square, okay, distance square. That means here if one axis is there and a point is rotating about this, then here what I will tell, this distance, suppose r perpendicular distance, this mass is there, then this moment of inertia I can write I equal nothing but m r perpendicular square. Remember here it should make a perpendicular distance, so perpendicular square I will write. Okay, or you can tell basically mass into some distance square, and here if SI unit you want to write, then for mass SI unit is kg, for distance SI unit is meter, so it will come kg into meter square, or dimension if I write m1 L to the power 2 T to the power 0. Okay, why it is coming? Because L to the power meter square, no, L to the power 2 will come, so T to the power 0. So also we can moment of inertia you can understand like mass in rotational mechanics. Okay, that means here So what is this force you are writing? Angular force. So basically force equal to mass times acceleration in linear mechanics, but in rotational mechanics you can write it is what? I times alpha. Okay, alpha is the acceleration, angular acceleration, and I is the moment of inertia. Okay, so you can write I times alpha. Now we will go to the next. Now 29, understand about some other thing that is comes under a pressure. So pressure is what? Now pressure is nothing but it is force by area. Okay, this formula is force by area actually, or you can symbol you can give P. You can write P equal to nothing but force by area. Okay, so force by area is pressure. So its unit is what? Unit force means it is Newton, area is meter square, Newton by meter square, or you can write it is Pascal. Okay, also it can written as Pascal. Okay, or you can write what? It's your Newton by meter square. And Newton by meter square is nothing but you can write kg. Newton is nothing but kg. Kg meter second to the power minus 2 divided by m to the power 2. Definitely this 2 will come up, so it will become how much? This one can be written, also can be written as what? Kg meter to the power minus 1 second to the power minus 2. This one also you can write. Right here you can write here m to the power 1, L to the power minus 1, T to the power minus 2. Okay. So you see kg power 1, m to the power minus 1 means meter to the power minus 1, which is L to the power minus 1, and second to the power minus 2 means T to the power minus 2. So in terms of MLT you are writing. So this is about your pressure. So force by area you can write. Similarly, some other physical quantity, suppose I want to write. So here number 30, I want to write stress. So stress symbol basically given as sigma. What is stress? Now stress is called basically force by area. So when you study mechanical properties of matter and all, that time stress and all will comes. So stress unit formula is what? Formula will be force by area, and this force is what? This force will be restoring force by area. Okay, remember here whatever this force comes, remember here whatever this force comes, this force is basically which force? And this force you can tell it is normal force. Okay, normal force by area is basically pressure. That means a surface is there, to this surface normally what force is acting, that is called basically pressure. But here what is this? Now it is this force I can write it. It is exactly I can write what? I can write it is Fr by A. So it is a restoring force. Fr means restoring force by A. Okay. So it is basically internal force, which basically what does? Now opposes the change in dimension of the objects. Here if I write SI unity, so force means it is same thing, Newton by meter square, or you can write Pascal, or just now we understand its unit is kg meter to the power minus 1 second to the power minus 2, or I can write m to the power 1 L to the power minus 2 T to the power minus 2. Okay, m1 L to the power minus 1 T to the power minus 2, same dimension as compared to your pressure. So pressure is what? Newton by meter square, similar way that will come, and here you see it came also kg meter to the power second to the power minus 2. So here also same thing, m1 L minus 1 T minus 2. So pressure unit and stress unit is the same. Okay, remember that. Now here the next point will go. Okay, 31. So it comes basically strain. Another quantity comes strain. So strain sigma epsilon we basically take symbol. Okay, what is strain? Now strain is nothing but that is your formula will be change in dimension. Change in dimension by original dimension, by original dimension. Remember, change in dimension by original dimension. So here that means here you can write suppose like longitudinal strain you can write delta L by L. So change in length by original length. Change in length unit is meter, its unit is meter, so no unity. So it will have no SI unity. But dimension also if you want to check, if you know unity, then dimension also will not come. So m0 L0 T to the power 0. Okay. So here no unity and no dimension. So this is the strain. This is the strain. So this is there are a different type of strain, that is longitudinal strain. Okay, you can write x epsilon x also, lateral strain, or basically volumetric strain. All type of strain will have no unity or no dimension. 32 understand. Next is we will understand one modulus of elasticity, that is basically Young's modulus. So you can write here one quantity Young's modulus. So Young's modulus symbol is basically given as y, and what is this y? So y is nothing but same thing, it is basically stress by strain. Okay, remember it is stress by strain. Okay, or you can write it is basically what? Now stress by longitudinal strain. Okay, or you can write here it is force by area by delta L by L. Okay, so this is your what? This is your Young's modulus, and strain is having no unity. That means Young's modulus unity will be equal to stress unity. So I can write here its unit is nothing but exactly same kg meter to the power minus 1 second to the power minus 2. Okay. Now here you can write, or you can write this one what? It is right can Pascal. Okay, or you can write Newton per meter square. Okay, or you can write Newton per meter square, and dimension will be m1 L minus 1 t minus 2. Okay. So here this is Young's modulus. Similarly, there are other type of modulus of elasticity is there, like bulk modulus and modulus of rigidity. That all things will come what? Under this. So that's unit will be what? Now stress unity or pressure unity. Understanding? So that one also remember. So let me write also 33. Okay, you can come across modulus of that bulk modulus come. So bulk modulus, or you can symbol you can give basically B. Okay, so bulk modulus what? Bulk modulus is basically what? Here it is stress by strain, but it is what? It is basically normal stress by volumetric strain. Okay, so this is the basically bulk modulus, and here if I write unity, so stress unit only will come, that is basically kg meter to the power minus 1 second to the power minus 2, or you can write Newton by meter square, or you can write Pascal. Okay. So stress, because volumetric strain means change in volume by original volume. Remember this volumetric strain is what? Change in volume by original volume. So it will have no unity because volume is meter cube by meter cube. It will get cancelled. So here what is happening? Now here this one is coming. So here you can write m to the power 1, L to the power minus 1, t to the power minus 2. This is your bulk modulus. Now we will understand 34. Shear modulus. Shear modulus also called as modulus of rigidity. Okay, or symbol you can give as eta, or sometimes symbol you can give also capital G, no issues. Okay. Now you see, so here this shear modulus or modulus of rigidity is nothing but what is that? That eta is basically shearing stress by shearing strain. That way also you can do. So you can write also eta equal to nothing but the stress is basically force by area, and the shearing strain is phi. So you write eta equal to nothing but F by phi. Okay. So here you see strain means it will have no unities. Again same thing, eta unit will be same unity as equal to pressure. So kg meter to the power minus 1 second to the power minus 2, or you can write Newton by meter square, or you can write Pascal, or you can write m1 L minus 1 t to the power minus 2. Okay. So this is your shear modulus or modulus of rigidity. Okay. Now here the last point we will understand today, 35. So we will understand about one velocity gradient. Let write here, it is velocity gradient. Okay. So what is this velocity gradient? Now remember, always whenever gradient quantity coming, or no, like gradient word is coming, that time remember it is some quantity by length. Velocity gradient means velocity by length. Suppose I am telling potential gradient, then potential by length. So this type of things you can tell. So what is this velocity gradient? Formula will be what? Velocity by length. Okay. So velocity gradient is nothing but velocity by length, and its SI unit you want to write. Velocity SI unit is meter by second divided by length means it is a meter. So it will come how much? Second to the power minus 1. So that means you can write m0 L0 t to the power minus 1. Understanding? And the second to the power minus 1 is nothing but it is the unit of frequency. That means here what is happening? So here velocity gradient unity is same as, or dimension is same as either frequency or 1 by time period, because time period unit is second and frequency is nothing but 1 by time period. So that's why, so velocity gradient is what? Now velocity gradient, okay, unity is same as coming what? Frequency or 1 by time period, 1 by time period. Sometimes question will come which dimension is matching with what, okay. So this is what you are understanding in the today class. So most of the quantity we understood starting from translational to rotational, and next class onwards we will be going to understand some other physical quantity, okay. So some 11th class physical quantities and 12th class physical quantities will complete. After that we will come to the dimensional problems and that equations and some other type of questions on dimensions, okay. I hope you understand this. So we understand today all the physical quantity and how to write its dimensions, okay. Now we will solve some MCQ based on this. Now here understand the MCQ. The dimensions of Planck's constant equals to that of what? Some 4 options are given. See here it is a NEET 201 question, a previous year question. Now here they are telling energy, momentum, angular momentum and power, okay. So while teaching the class I told actually Planck's constant unity is equal to what? That unity or dimension is basically equal to angular momentum unity, okay. And that formula also I wrote there, L equal to how much? NH by 2 pi, okay. So N is a number, pi is a number, 2 is a number, they will have no unity, and L unity will be equal to H unity, which is nothing but what? Joule into second, okay. Or you can write basically kg into meter square second to the power minus 1, okay. So this is your angular momentum unity. So answer will be C option, correct. Now come to the next question. So here you see, so this is your NEET 2020 question. So just recently they asked dimensions of stress are what? Stress, just now we studied stress. So what is stress? Now stress is nothing but restoring force by area, or you can write basically Newton by meter square you studied, right? So and Newton is nothing but what? Newton is kg, meter to the power 1, second to the power minus 2 divided by meter to the power 2. So this meter will go up, it will become how much? It will become kg meter to the power minus 1 second to the power minus 2. So this expression already we have given in that previous slides. So it is nothing but how much? Kg means m to the power 1, meter to the power minus 1 means L to the power minus 1, T to the power minus 2. So your answer will be D option. Answer will be D option, okay. So dimension of stress is nothing but this one. So simple question, already last slides you understand everything. Which of the following pairs does not have same dimensions? Okay, so frequency and angular velocity. So we have already discussed frequency symbol I gave F, that is called linear frequency. Angular velocity is basically omega we gave, and frequency nothing but what it is? That is your basically what? Hertz unity, or you can write what? 1 by second unity. So angular velocity is what? Angular velocity is radian by second actually, but its dimension if you write radian dimension is no dimension, m0 l0 only t to the power minus 1 comes. So frequency also comes what? m0 l0 t to the power minus 1. Then definitely frequency and angular velocity will have same dimensions. So they are telling who does not have same dimension. So this answer cannot be correct, okay, because they have same dimensions. Now come to angular velocity and velocity gradient. So angular velocity same thing, we told basically angular velocity is omega, which is basically m0 l0 t to the power minus 1 dimension, and if velocity dimension, velocity gradient dimension will check, that is also m0 l0 t to the power minus 1, because it is nothing but velocity by length, okay. Velocity by length is nothing but second to the power minus 1 unity, which is m0 l0 t minus 1. So that means this cannot be answer. Now see pressure gradient and force gradient. So already I told gradient means what? Any quantity gradient telling. Pressure gradient means pressure by L, and force gradient, that means force by L. So that means you are understanding clearly pressure is not equal to force, right? Okay, so that's why here what will happen, because pressure is force by area. So definitely these dimensions will not match. From formula itself you can calculate, no need to go for dimension calculation, okay, because down LL will be there and pressure is not equal to force. So that's why this answer will be correct, which is having not same dimension, okay. So pressure gradient and force gradient having not same dimension. And stress and bulk modulus will have same dimension, already we have discussed, so this answer cannot be correct. So answer will be option C, answer will be correct. I will go to the next question. The expression m1 L0 t to the power minus 2 represents which of these quantities? Impulse, angular impulse, momentum and force constant. Listen, impulse, this angular impulse, momentum already we have discussed. Okay, now understand what is force constant. Now force constant is basically K, represented as K, that is force by, okay, displacement, or you can write force by x. Okay, K is basically force by x, or its unit will be Newton by meter, or dimension if you will check, it is m1 L0 t to the power minus 2. Okay, because Newton dimension is m1 L1 t minus 2. So L1 is there, so it will become m1 L0 t minus 2. That means here itself you understand that this force constant is exactly equal to what? m1 L0 t minus 2. Okay, but when you approach the question, you see here impulse and momentum, they both are having same unity, because impulse is change in momentum. So definitely these two cannot be answer. You can check between these two, and a force constant now I defined you, and this is exactly matching with that. So you can tell answer is what? Force constant. Okay, and angular impulse, already I told angular impulse is nothing but that I took J prime, which is torque into delta T. Okay, so and it cannot be answer actually. So here answer will be force constant, which is option B. Now I will go to the next question. So which of the following pairs physical quantities has different dimensions? Now stress and pressure. See, stress is basically I told it is Newton per meter square, because restoring force by area, so Newton by meter square. Pressure is also Newton by meter square, because force by area. So they will have same dimension. So but they are asking which of the pair physical quantity has different dimension. So this cannot be same dimension, so this cannot be answer. Young's modulus and energy density. Young's modulus also exactly equal to a pressure unity, so you can write Newton by meter square. Now understand what is energy density. So energy density means it is energy by volume. Okay, remember, suppose pressure density, energy density. So that time when we will tell, always remember energy by volume. Okay, energy density means energy by volume. Pressure density means pressure by volume. So energy unit is what? Joule by meter cubic. And joule is nothing but it is Newton into meter by meter cubic. Now here you can write it is Newton by meter square. So Newton by meter square is nothing but Pascal. Okay, which is basically like coming what? Pressure, because meter will cancel to meter cube, it will become Newton by meter square. So pressure means, that means here also energy unit is energy density unit is nothing but Newton by meter square. Now come to next, density and relative density. Now understand, so this cannot be answer, so this one you have to check. Density means what? Density is basically kg by meter cubic. Already you know mass by volume is density unity. But if relative density we want to understand, relative density is what? Now relative density basically tells density of any liquid divided by density of water. So relative density, when you want to write what it is, that is density by density. It is nothing but it is what? Density by density. Okay. So that means density of any liquid medium or liquid or any medium divided by density of water. So that's why density by density what it will got? It will get basically 0 unity. Here it will meter kg by meter cubic, kg by meter will get cancel. So you will get no unity, no dimension. So that means here it will have 0 dimension, but this dimension will be kg by meter cubic dimension, or m1 L to the power minus 3. So definitely this will have different dimension. So you can write density and relative density. And energy, torque, already you know energy and work same unity, torque also same unity, Newton into meter or joule basically. So this will cannot be answer, so answer will be option C. So here answer is option C. I hope you understand all the concept what we discussed, and physical quantity and its units and its SI units and its dimension formula. There are different physical quantities we discussed, okay, starting from translational mechanics to rotational mechanics. Okay. So next class will be discussing some other physical quantities, and based on that we will do MCQ. Okay. And here also we solved NEET 2020 MCQ and previous year MCQ and some practice MCQ. Similarly, we will be solving question and uploading more videos on the same topics. Okay. So I hope you understand. Thanks for watching. Like and subscribe Vidhyalakshmi NEET Academy YouTube channel. All the very best. Thank you.